Bismillahirrahmanirrahim. Mrs. Sobia Suhail is here. Assalamu alaikum, my dear students. How are you? Hopefully doing well. In this video, specifically, I will explain derivative of trigonometric functions. Okay, the topic I have selected from unit number 2 from class second year. Okay, it will help you in doing the exercise 2.5, but still before doing 2.5 exercise you have to find out the derivative of trigonometric function first. Okay, so derivative of the trigonometric function, like we have 6 trigonometric ratios: sin x, cos x, tangent x. Okay, then sine, derivative of sin x, derivative of cos x, derivative of tangent x. The derivative of sin x is equals to cos x. Derivative of cos x is minus sine of x. Derivative of tangent x equals to secant square x. Okay, then derivative of secant, secant x, cosecant x, and cotangent x. Derivative, derivative. Okay, secant x derivative is secant x, tangent x. Derivative of cosecant is, as its derivative secant x, its derivative is minus cosecant square x. Tangent x, I write by mistake, I write the cotangent x derivative here. Cotangent x is equal to minus cosecant here, and cosecant x I will write here. Cosecant x derivative is that minus cosecant x and cotangent x. There is only one trick of keeping that all derivatives in the mind, that sine and cosine, they're giving opposite values. Okay, but cos, derivative of cos. Okay, first tangent and cotangent. Cotangent x, tangent and cotangent. Tangent is secant square, cotangent is cosecant square. Okay, secant and cosecant, they also have respective values. Secant have secant tangent, cosecant have cosecant cotangent. Okay, now one more point which is common over here: all the values which are starting with the c, they have negative signs. The derivative of starting with minus, minus, and minus sign. Okay, now these are the derivatives, and you can go to their proof also, that how to derive this by first principle. You can say by first principle. Question could be like by first principle, or by ab initio method. Ab initio method, or it is also called by definition. By definition. Okay, differentiation. Differentiation by first principle, differentiation by ab initio method, differentiation by definition. Okay, differentiation. It's okay. How to go for that? Let's take our derivative first. Okay, we have to prove that the derivative of sin x equals to cos x. For this proof, what we can do, we can take this function, that let y is equals to sine of x. So for the first principle, what we are doing, first we are increment, giving the increment. So first step is, if y is increased to delta y, so x will be increased to delta x. Now see the difference between these two. Y plus delta y minus y means new value minus the old value. Sine of x plus delta x excuse me, sine of x. Okay, now delta x divided by the change, apply the limit. Delta x approaches to 0. cancel. So limit delta x approaches to 0, delta y by delta x. Limit delta x approaches to 0. This sine of x plus delta x minus sine of x over delta x. It's okay. If we apply the limit over here, this will become 0. So sine x minus sine x 0. 0 by 0, 0 by 0 form we have to avoid. Okay. So what we can do, we can apply the algebraic manipulation, algebraic strategy to avoid that term. If we see properly, so this formation is taking sine of p minus sine of q. So it is equal to what? Sine p plus sine p minus sine q is equals to 2 times. Continue. Okay. For the first time, if you forget about the identities, you can keep the reference that sine of alpha plus beta is equal to this. Sine of alpha minus beta equal to sine alpha cos beta minus cos alpha sine beta. Yeah, we have to subtract because this is kept as p, this is kept as q. When we are subtracting, so this will be sine of p minus sine of q. Direct quick derivation I'm giving you. This will be cancel and 2 times cos of alpha sine of beta. Now what was alpha? Because we kept as this alpha plus beta as p and alpha minus beta as q. So adding them to alpha. So alpha will be equal to adding them p plus q over 2 to divide them. Okay, understand now? Now you can give me the answer that 2 cos of what is alpha? P plus q by 2 and sine of what is beta? P minus q by 2. Now remember about that identity? It will be used many times in proof of these identities. Keep the strategy in the mind. It will take only 2 minutes if few people are forgetting about the identities. Okay, write down sine alpha plus beta identity, alpha minus beta identity, or open these identity into your mind and then check. You have to add, then add the first term will be there. If you have to subtract, then the second term will be there. Okay, so when subtraction sign is there, 2 cos of the alpha and sine of the beta will be there. Okay, so like this, apply this over here. So it will become limit delta x approaches to 0 and then 2 times cos of what is alpha? X plus delta x and plus what is beta? X divide by 2 sine of x plus delta x minus x divide by 2 and that is delta x also, which was written over there. Now limit delta x approaches to 0, 2 times cos x plus x 2x 2x plus delta x divided by 2 sine of x minus x cancel, delta x divided by 2 is there. Still, if we are applying the identity, this will become 0. So sine of 0 will become whole 0. So we have to avoid the 0 also. Limit delta x approaches to 0. I forget this delta x. Now write down this cos of x plus delta x by 2. I shift 2 down here, both side. Okay, and then next this I want to make the identity. I want to complete the identity of sine theta by theta, which will be equal to 1 if limit theta approaches to 0. I want to make the formation of that identity. Sine identity is theta as delta x by 2. So sine of angle is delta x by 2. Can I shift this angle down? Delta x. I want by 2 also. Can I write by 2 here and by 2 here? Okay. So that the identity is complete till here. This 2 is still left over here. I just shift this delta x over down Then completing the angle delta x by 2. For completing the angle, I multiply and divide by 2 here. Okay. Now sine theta by theta is completed till here. Separate out that where you are applying the limit. Limit will be applied on this 2 cos of x plus delta x by 2, and limit will be applied on the second term also, that is sine of delta x by 2 over sine of or delta x by 2. This 2, can I shift this 2 out here? Okay, so now I can apply limit. Apply the limit. When I apply limit, this side becomes dy by dx, and this side becomes cos of x plus 0 1. So cos of x, dy by dx equal to cos of x. Return the value of y, d by dx of sine of x equals to cos of x, and proved. It's okay. In the same way you can prove the others also, but you have to prove. Let's try the next one. Okay, prove that, yeah, derivative of cos x equals to minus sine x. Okay, so in this one also, let y is equals to cos of x. Y plus delta y equals to cos of, do increment in the variable, difference of new value to old value. Okay, y plus delta y minus y, cos of x plus delta x minus cos of x. Okay, take limit, divide by the change ratio, and take the limit in the same step. Okay, now limit delta x approaches to 0, delta y by delta x, limit delta x approaches to 0, here become cos of x plus delta x. Yeah, now what happened? Apply the formula. Now tell me that, as I told you the trick, cos of p minus cos of q. Think about the identities. Subtraction means second term will be added up. Yeah, sine with minus minus. Minus 2 times sine and sine. First p plus q by 2, and second p minus q by 2. Very good. What I said, how I give you the trick, let me explain it also over here now. I said that cos of alpha plus beta equals to cos alpha cos beta minus sin alpha sin beta. Cos of alpha minus beta equal to cos alpha cos beta plus sin alpha sin beta. If we need to subtract, so subtract will give you this sign. Yeah, adding up of the second term means subtraction of these term will give addition of these term, and this one, this will behave like p and this will behave like q. So alpha will be changed as p plus q by 2, and beta will be changed by p minus q by 2, solving in the simple form. If still you don't understand, go to the first year identities proof. Okay, so as we know this one identity, so we are going to use this over here. Cos of alpha, alpha is this, means p is this and q is this. So when we will use it, it will become limit delta x approaches to 0 minus 2 sine p x plus delta x plus 6 divide by 2, and sine x plus delta x minus x divide by 2. Is that okay? After that, what happened? Limit delta x approaches to 0, sine of 2x, yeah, 2x plus delta x divide by 2, sine of, yeah, cancel delta x by 2, Now, as we have done in the next and the previous step, delta x, I forget what we will do. Limit delta x approaches to 0, minus 2 will kept here, sine of x plus delta x by 2, sine. This I will write angle in this form. This I will shift here. Okay, delta x. To change the complete angle, multiply divide by 2. Now till here identity complete. So I will apply the limit. This will become dy by dx, and this will become minus 2 sine of
X plus.
yeah x plus 0. This will become 1 by 2. This 2 you can cancel the start also. Dy by dx equals to minus sine of x. Replace the value of x. Replace the value of y.
Cos.
So d by dx of cos of x equals to minus of sine of x, and hence proved. Any problem till here? Thank you so much. Hopefully you also understand well. So if there will be any problem, you can discuss with me and send me in the comment section, and like and subscribe my video. Thank you so much. Until then, Allah Hafiz.